Hello everyone, welcome to Catalyst Chemistry. As we discussed last class, important point about what hydrogen spectrum. Okay, line of what hydrogen spectrum. In that we have draw the diagram. Okay, that is most important. The first one is what Lyman. After that, what Balmer is there. Next one is Paschen. After that, bracket. The next one is what Phi Fund. Okay. After that, H alpha line, H beta, H gamma, H delta line. Okay, all these points are what most important. Bear in mind. Okay. In this case, what these 5 scientists gave a different formula. Okay, every scientist gave a different formula along with what change in values of what n. Finally, the Redberg gave a final formula, that is most important formula, that is indicate what you are going to find out a wavelength is equal to what, that is 1 by lambda is equal to what RH is there, that is called what Redberg means what Redberg constant for hydrogen. After that, 1 by n1 square minus 1 by n2 square. Okay, that is important. n1 is less than what n2, means what n2 is always greater. By chance n1 equal to 1 is there, n2 equal to 2, 3, so on. Okay, that is important. Make it perfect. They are going to ask you what theory exam as well as what competitive also. That point is important. In this case, the important point is what, which in Lyman, Balmer. Lyman is there, that is UV. Balmer is what visible. The next one is what IR is there. IR means what, that is the first one is what near IR, middle IR, far IR. Okay, far IR is there, that is indicate what Phi Fund. All those things are most important. IR means what infrared radiations. What is UV? Ultraviolet. Ultraviolet radiation is different. Visible. Visible means we can see through what naked eyes. That's why the Balmer gave a first formula, that is what important. In that case, compulsory you have to take, that is what 1 by n, means in Balmer what is the value of n? N is always what 2. Okay, that is important. Today we are going to discuss the next part, is the most important, about what Bohr's atomic model, means what the postulates of Bohr's theory. In final exam as well as what competitive exam, this is the most important, Bohr's theory. Okay, bear in mind, make it perfect. Every point I am going to explain. In this case, this is having in some book they are given 5 postulates, in some book they are given 6, 7, etc. I will explain the 7, means I am going to divide it what smaller, means smaller sentence. Okay, that is why in this case I am going to explain 7 postulates in Bohr exams, Bohr atomic model. Okay, postulates important. Okay, make it perfect. First listen carefully, after that you have to note on the every points. Okay, in this case, what are the first postulates? Means in this case, this Bohr's atomic model come from what hydrogen spectra. You know very well about that the line of hydrogen spectrum is there, no? In that we are going to study about a spectra, but in this case we are going to study about what is the structure, how behavior takes place, what hydrogen how behavior takes place. Okay, that is why in this case the continue part, this Bohr's atomic model come from what hydrogen spectra. Okay, that is important part, means okay, means in this case where electron is there exact revolving around the nucleus, that point we are going to study. The first point, just see here, electrons, means you know very well about that hydrogen atomic number is 1, no problem. After that, in hydrogen not having a neutron but 1 electron. Isotope of hydrogen is having a what neutron, that is what basic, bear in mind. Here is electrons always move around the nucleus. Okay, just see here, in this case I am going to draw the diagram. This is indicate what positive. Positive means what nucleus, you know very well about that the Rutherford model is there, no, that Rutherford model. Before that I am going to explain one point here only. What is the drawbacks of Rutherford? You know very well about that they are going to pass what alpha particle, the alpha particle hit the nucleus, it come down, what that is what bond angle is what 180 degree. That time the Rutherford come to conclusion at the center positive charge is there, but alpha particle is indicate what alpha is also positive charge, the nucleus is also positive charge. When positive attraction takes place, automatically what means positive collision takes place, that time what 100% repulsion takes place. Rutherford come to conclusion at the center one positive charge is there, but actually he is also don't know that is nucleus. Okay, that is what most interesting point. Just here in this case I will tell you here only what is the drawback of Rutherford. I am going to explain first Rutherford drawback, after that I will explain this point. Okay, just here better I will explain here. I am going to explain about what. Now tell me, drawback of Rutherford. Rutherford said that this is a nucleus. This nucleus usually containing what? Proton plus neutron. Okay, no problem, proton plus neutron, but hydrogen is not having a neutron. Okay, but isotope of hydrogen is having a neutron. In this case, what happens? This is what the electron. This is what the electron revolving around the nucleus. Okay, Rutherford said that electron revolving around nucleus, when revolving around the nucleus continuously, it loses energy and fall into the nucleus. This is the main drawback of Rutherford. Rutherford showed that the electron revolving around the nucleus continuously, when it loses energy, directly fall into the what? Nucleus. But this concept is wrong. This concept is what? Wrong. Why this concept is wrong? We are going to study about what? Bohr's atomic theory. Now listen to Bohr's atomic theory. This is the what? Nucleus. Okay, in this case what happens? The electron revolving around the nucleus. Okay, this is important part. Just here in this case, all these are indicate what? Orbits. We called what? Orbits. Orbits having a fixed energy, that is indicate quantized. We call what? Quantized. What is the meaning of quantized? Quantized means what? Available fixed energy. Okay, I will explain later. No, don't worry. Okay. According to definition, I am going to explain. It is very easy to remember. According to first postulates, the electrons always move around the nucleus only in certain circular orbits. These orbits are known as stationary states. This is the first postulate. Just here in this case, this is the what? Electron. The electron revolving around the nucleus in an what? Circular orbits. Means what? Circular orbit. These orbits are called stationary cell or stationary states. Means in this case what happen? Here is nucleus is there, here electron is there. The distance between nucleus and electron is a fixed. The distance between the electron and nucleus is a fixed. Okay, in this case what happens? The electron is always revolving around the nucleus. The electron will not fall into the nucleus. Rutherford what he told? The electron continuously rotating start loses energy and fall into the nucleus. But in Bohr's atomic theory, not like that. The electron revolving around the nucleus in a circular orbit. Stationary. Stationary means what? That is, we called it as what? Constant running, constant revolving. Okay, that is indicate most important. In this case here nucleus is there, electron is there. In this case what happens? The distance between these two is a fixed, that is fixed distance. The electron revolving around the nucleus in a circular orbits is called what? Stationary states. Bear in mind, important, circular orbit are known as, indirectly these orbits are known as stationary states. Stationary states means what? Try to understand, this one is indicate orbits. The next, what is the meaning of orbit? Means what? In this case the electron places, it is having a what? Energy. It is having a fixed position and fixed energy. Okay, that is important, that is indicate what? Orbits. I am going to write here only. Places electron fixed position and energy. Fixed position and energy. It is a fixed position. Electron is a fixed position. Fixed position means what? In this case, fixed position means not only present at the only one place. That is not a fixed position. Fixed position means what? The distance must be fixed. The distance between the nucleus and electron must be fixed. Means the electron, just I will tell you one more point here only. I will explain. Okay, just here in this case, here is what? Nucleus is there. Okay, the electron revolving around the nucleus, here one electron is there, this electron revolving around the nucleus like this. Okay, in this case up to here the electron revolving around this position. After that the electron will come near to nucleus, not like that, not like that. Okay, in this case what happens? Here is distance is there, no, the distance between the nucleus and electron is a fixed everywhere. Everywhere, that is most important. The electron here is there, fixed, electron will come here, in this case also fixed. How much distance is there? In this case also that much distance. Okay, that is most important. That's why in this case, that's why the electron is in this case what happened? Stationary states. That's why orbits. Orbits means what? That is having a fixed position and energy. Orbits means what? Electron. Don't think that here on line is there, this line is indicate energy, not like that. This electron is having a energy, this electron is having a energy, electron is having a fixed position. Okay, that is most important. Okay, The first postulate is completed. The next postulate is there, the Coulombic force, the Coulombic, the name of scientist. The Coulombic means what? Electrostatic force. The Coulombic means what? Electrostatic force. Bear in mind, important point, electrostatic force. Electrostatic force means there must be a one positive and one negative, then only we called electrostatic force or a Coulombic force. Just see here, the Coulombic force of attraction between the electrons and the nucleus hold the atom together. Very simple postulates. Here is there positive charge, the electron is a negative charge. In this case, which force is there? Coulombic force. What is the meaning of Coulombic force? Electrostatic force. That electrostatic force is a fixed. Here is there, here is what? Here electron is there, in this case fixed position, in this case also same Coulombic force only possible. Okay, that is why in this case this attraction is there, this positive and negative attraction is there, then only the electron will not fall into the nucleus. Okay, according to Rutherford told the electron fall into the nucleus, but according to Bohr not like that. In this case what happens, this electron is there, this nucleus is there, 100%. In this case what? Force of attraction is there. If the force of attraction is there, the electron will not fall into the nucleus. Okay, this is a fact. Okay, that is why this is indicate what? Second postulates. The next one is what? Third one. As long as electrons remains in the stationary states, there is no absorption or emission of radiation. Just here in this case, here electron is there. Here electron is there, this is revolving around the nucleus, this is called what? Stationary state. The electron present in the stationary state, there is no absorption or emission of radiation. Means what? That is point also important, I am going to explain here only. After that next point is there, similar point here is there. Just here in this case, this is nucleus, the electron revolving around the nucleus. Okay, this is what? Next orbit is there. Just here, if stationary states is there, this is do not undergo absorption or emission of radiation. Okay, that is what most important point. When we are going to supply some amount of energy, that time this electron absorb radiation, it can go into what? Higher level energy. Okay, that's why this is important. As long as electrons remain in the stationary state, there is no absorption or emission of radiation. Okay, it will not absorb or emit radiations when it is present in a stationary state. Okay, that is most important. Okay, next point. The next one is what? Fourth postulates. Each stationary states. Each stationary state. What is the meaning of each stationary state? Means what? Here one electron is there, this is act as a stationary state. The next here one electron is there. In this case also distance must be fixed. In this case also distance must be fixed. This electron is act as also stationary state. Each stationary state is associated with a what? Definite quantity of energy. You have to take every stationary state is having a what? Definite quantity of energy and fixed position. Okay, that is important. Okay, that is why stationary states are also called energy levels. These are called what? Energy levels. Energy levels or energy cells. These cells are designated as K, L, M and so on. Otherwise, you have to write numbering 1, 2, 3 so on. Just here. Here one cell is there. This is the what? K cell. This is the L. Next this is the M. Next one is there N. You have to, these are indicate what? Cells or what you are going to call energy levels. Otherwise, K, L, M and you have to write, otherwise you have to write 1, this is the first L, this is the second, this is the 3, 4 so on. These are indicate what? Cells. Every cell is having a what? Fixed energy, fixed position. That is why they are going to call what? Definite quantity of energy, every cell. Next fifth one, the number of stationary states. The number, in this case they are going to use word what? The number of stationary states or energy levels is determined by the quantum condition that the angular momentum of integral multiple of h upon 2 pi. Just here in this case this is very interesting point is there. In this case important point is what? Angular momentum. The next question, what is angular momentum, we are going to study. Okay, this is slightly related to what? Physics. I will tell you here only. Okay, just here the number of stationary states. The number means what? 1, 2, 3 so on. This is a number. The number of stationary states or energy levels is determined by the quantum condition. Just here in this case I am going to draw the diagram. This is what? Nucleus. In this case what happens? The electron revolving around the nucleus. Here electron is there. Okay, here electron is there. Every electron is having a mass. That is what basic funda, very simple. Every electron is having a what? Mass. In this case what happens, this electron moving like this means what? In this case this electron move like this, okay, no problem. Means in this case this force is like this, force is what? Like this, because of the electron is having a what? Moving means what? Vector quantity. This is I am going to call as tangential force. What I am going to call, that is called tangential force or tangential velocity. This is represented by what? V. Every electron is having a tangential force or tangential velocity. Okay, here electron is there, it can move in this direction. Here electron is there, this can move in this direction. Here electron is there, this can move in what? This direction. Okay, here electron is there. That is why in this case every electron means what? In this case this one electron first position, this can second, here is there, it can come here, again it can come here. That is why in this case what happen? Every electron is having a what? Mass, and in this case this is electron is having what? Tangential force. After that in this case here nucleus is there, here electron is there, this distance is indicate what? R, we can take distance also. That is why in this case what happen? Mass is there, after that velocity is there. This is called what? The mass into velocity is indicate what? Momentum, angular momentum. After that you have to add what? 1 r, because of distance between the electron and nucleus. This totally mvr is there, this point is indicate what? Angular momentum. Okay, in this, in physics you are going to explain means what? That is L equal to mvr. L if you are going to show like this, means this one is indicate what? Vector quantity. Two quantities are there, one is scalar quantity, another one is what? Vector quantity. Okay, that is why in this case L arrow mark is there, this is called vector quantity. In this case angular momentum is also what? Vector quantity only. Okay, that is why in this case what happen? The important every moving electron is having a what? Angular momentum, that is what? Fixed. Okay, this is important, bear in mind. Okay, next after that, up to this it is clear, this one is indicate what? Angular momentum. The next one more point is there, that point is what? Integral multiple. What is the meaning of integral multiple? Means n equal to 1, 2, 3, 4 so on. You have to take round figure, do not take a fraction. Fraction means what? 0.5 is there, 1.5 is there, 2.5 so on is there. No, do not take like that only. Just here I am going to explain one more time here only. That integral multiple of that is h upon 2 pi is there, no? N equal to what? 1, 2, 3, 4 so on. This one is indicate what? Integral multiple. Okay, just here I am going to draw one more time diagram. Okay, just here nucleus. After that what happened? The electron revolving around the nucleus. Okay, this is what according to Bohr theory. Okay, in this case n equal to 1, 2, 3 so on. In this case what happened? The angular momentum is there. This is m is indicate what? The mass of an electron. M e is there, no? Mass of an electron. P is what? That is velocity of an electron, means what? Tangential velocity. After that r means what? That is called, you have to write expression. Okay, what is the meaning of r? That is the distance between the what? That is indicate what? The distance between the nucleus and one more is what? Electron. Okay, that is called radius of an electron we called. mvr equal to, here n is there, no? N equal to 1. I am going to fill n equal to 1. This is 1h by 2 pi. The first one. Here first electron is there, no? According to 1, 2, 3 so on is there, no? This is indicate what? Angular momentum. This first electron having a angular momentum, this is mvr equal to 1h upon 2 pi. Are you getting my point? Okay, very simple is there. In the mass of an electron, velocity r equal to, this is they are going to ask you what is the angular momentum of first cell electron. This is the angular momentum of first cell electron. Next I am going to write n equal to 2. In this case I filled n equal to 1. In this case I am going to take n equal to 2. This mass of an electron, velocity equal to, in this case 2h upon 2 pi, means indirectly what? H upon 2 pi only, no? The second electron is there. What is the angular momentum of second electron at the second cell? That is indicate what? mvr equal to 2h upon 2 pi. Every electron is having a angular momentum, 100% fixed. Every electron is having a what? Its angular momentum. The next I am going to explain. Here electron is there. This is having a fixed distance. And next one is what? This is having a fixed angular momentum of every cell. But in this case I am going to fill n equal to 0.5. Is it possible? Not possible. Just here in this case mvr equal to 0.5. What is that formula? H upon 2 pi is there. This is not exist. If you are going to get a 0.5, 1.5, 2.5, 3.5, so on, means indirectly electron is not exist. Electron is what? Not exist. Here 0.5 is there, the electron present in here. Is it possible? Not possible. Okay, electron must be present at the angular momentum of 1h upon 2 pi, that is the first cell. Second cell is a 2h upon 2 pi. Third cell is what? 3h upon 2 pi. So on. That is indicate what? Angular momentum of integral multiple of h upon 2 pi. This formula is important, bear in mind. Up to this what? 5 postulates are completed. The next remaining 2 to 3 postulates are there. I will tell next here only. You have to take screenshot. Okay. Okay friends, the next postulate, that is 6, 5 postulates are completed. The next one is what? 6th one is there. Just here, the most stable state of an atom is the lowest energy state, and their state is called ground state. Two states are there, one is ground state, another one is what? Excited state. Excited state means what? Higher energy, ground state means what? Lower energy. Just here I am going to explain. Okay, here is what? Nucleus. Next, after that, here is electron revolving around the nucleus in an circular orbits. Okay, that is stationary states. Here is their electron. Okay, this electron revolving around the nucleus, no problem. Okay, in this case what happened? The most stable state here is there. No, this is indicate what? Most stable state. This state is called what? Ground state. We called what? Ground state of an electron indirectly. Okay, ground state. This ground state is a stable state. Ground state is a stable state. First point is what? Means sixth point is clear. The most stable state of an atom is the lowest energy state, and their state is called stable, means ground state. Their state is called what? Ground state. Ground state is always stable. The sixth one completed. Next, seventh one. An electron absorb energy and get excited from its ground state to the higher energy levels or higher energy state. The excited state being unstable. The excited state being what? I used the word what? Excited state means what? Higher energy state being unstable. The electron return to ground state emitting the absorbed energy in the form of electromagnetic radiation. Very simple. It is a look like a very lengthy sentence, but it is a very simple. I will explain, just listen here. What happened? I am going to supply some amount of energy on this electron. Means in this case already it is a stationary state is there. Why? When we are going to call a stationary state, it do not absorb or emit radiation, that state is called stationary states, no problem. I am going to supply some amount of energy. That energy absorbed by the electron, it can move from lower energy to higher energy. Lower energy to what? Higher energy. This higher energy is called excited state. This higher energy is called what? Excited state. The excited state is always unstable state. The electron not stay longer time in a excited state. Electron is always stay in a what? Lower energy state, means that is lower energy is stable. Okay, that is why in this case what happens? When electron absorb radiation, it can move from lower energy to higher energy. The higher energy is called excited state. The excited state is always unstable. Excited state is not fixed. Okay, again electron come into its original state, means what? Lower energy state, start emission of radiation, start emitting the electromagnetic radiation, start emitting the electromagnetic radiation. This is indicate what? Seventh point. Okay, is it clear? This electron is a lower energy state, ground state. This one is called excited state. Excited means electron is not always present in an excited state. It can come down. It can come down to what? Original state. Okay, this is what? Postulate 7. Okay, next one is what? The postulate 8 is there. Means in this case another we can continue problem. In this case here only I will explain this 8th one later. Just here in this case what happens? Here is there. I am going to means in this case what, this is the energy 1 means this is the energy 2, this is the energy 1 we call, that is E2 minus E1. This is initial energy, this is called what, final energy. Okay, in this case we are going to get a what, difference these two. E2 minus E1 is there. In this case I am going to call this is a h nu. This one is what, h nu, Planck constant. Next one is what, frequency. Means you know very about that the line spectrum in spectrum is there, no, that is absorption spectrum, emission spectrum. In this case which spectrum means what, this is a emission spectrum. It can emit the radiation. These radiations I am going to put a one photographic plate, in that time I am going to get a what, spectrum like that. In this case what happen, if radiation is there, electromagnetic radiation is there, with the help of the electromagnetic radiation we are going to find out a frequency, next we are going to find out a what, wavelength, next we are going to find out a wave number, no problem. In that point the difference is there, no difference between this one and this one, we are going to calculate what, frequency, that is indicate what, delta E. Delta E is equal to what, h into nu. In this case what, h I am going to, as it is I am going to take a nu equal c by lambda. C is what, velocity of light, nu is the what, wavelength. In this case what, delta E is there, no, what is the meaning of delta E? E2 minus E1, I am going to write what here, E2 minus E1, no problem. In this case what happen, I need what, wavelength I need, just I am going to take like this. In this case what, here is what, E2, here is the E2 minus E1 divided by what, h into c. This is what, final formula. This is what, final formula. Okay, this one is E2 minus E1 h into c, means what, it is a look like a, it is a look like a what, Rydberg formula. With the help of this one we are going to find out the, what is the wavelength of this emitted radiation. What is the wavelength of what, emitted radiation? We are going to calculate a frequency also, we are going to calculate the difference between two states, energy 1 and energy 2 states we are going to calculate. Everything in this case we are going to calculate with the help of what, this formula. This formula is the most important, it is a look like what, Rydberg formula. With the help of 1 by lambda is there, no, here E2 minus E1 divided by what, hc. Okay, right. The next one, the last one is what, eighth postulates by increasing orbit number. By increasing orbit number, what is the meaning of by increasing orbit number? Means here 1 orbit, 2 orbit, 3 orbit, 4 orbit. When increases the orbit number, the energy difference between successive orbits is going to decrease. Just here in this case I am going to draw one more time. Here is nucleus is there, here one orbit is there. The next one is what, here orbit is there, the next here is there, like this, the next here is there. Okay, just here. When increase the orbit number, the successive difference between orbit is going to decrease. Just here, here nucleus is there, here orbit is there, this difference is more compared to what, this one, but this difference is what, less, again difference is what, less, again difference is what, less. The difference between two successive lines is going to decrease. When you are going to increase the orbit number, two successive orbit difference is going to decrease. Okay, this is what, last one, eighth postulates. Okay, up to this what, postulates of Bohr's atomic theory completed. The next point we are going to study about what, limitations of Bohr's theory. In this case what happened, all the postulates are not followed. Again scientists are there. One is what, de Broglie, Heisenberg uncertainty principle is there. In that case this Bohr's theory, again some postulates are going to fail. Okay, we will study next video limitations of Bohr theory. Okay friends, thank you.